Took 9 people alone to set up the antenna, which was a 25-foot tall mast. Here's us doing the pre-flight for the mechanical stuff. We had pre-flight for electrical as well. Here we're setting up the antenna mast, the 100-foot coax cable to go with that. There's the erected antenna mast, about 25 feet tall. And here's our command station inside of the U-Haul trailer. So we had 3 monitors. One is on the laptop here. That's all the navigation stuff. It shows us where we are on the map. We have a driver's monitor. That's what I was using. And we had a monitor for video capture. And thanks to that, you'll be able to see all our video. So here's a demonstration of how our chassis conforms to terrain very well. You'll see it flexes to it very well, but yet the main structure of the rover remains very stable. And this is something we were very impressed by ourselves. Throughout the design, we sort of discovered that this thing was going to be able to do some amazing things, and we built it, and it sure did. So here's some overnight work the day before the competition. Since we had such a reliable rover, we were able to be pretty greedy, so we added an audio system to it so we could get audio feedback as well. So unfortunately, it only picked up higher frequency stuff, so it sounded more like we're driving around a Sherman tank than a very silent electrical rover. It was pretty fun. And a lot of fun. We got enough sleep. Here you can see some of the lights on at night. These blue lights are our motor controllers. Some of the green lights here are DC-DC converters and status lights on our fabricated circuit boards that we had designed and sent out for fabrication. And that's our computer. So here's us at the equipment servicing task. You can see our shiny reflective surface reflecting all the sun's infrared energy there. Here we're flipping the first switch. And you can see this is our Cartesian coordinate arm, very much like York's, independently designed. We didn't know what they were working on until we had already designed ours. And grabbing the first plug, lifting it up, rotating it around. We had a sort of a wrist control on the end of our Cartesian arm, which allowed us to orient it correctly, and then with the Cartesian coordinates, we would move it into the correct position. And the plug's in. Here's the second task of that day. It's sample return. We had a scoop installed for this one, but on the same arm. Here we're investigating the first site. You'll see video of all this as well. This site here we didn't elect to actually take a sample from. It was frustrating for me as a driver and engineer. I just wanted to drive and dig, and our biologist kept looking around saying, no, how about we drive over here and look at there? And I was like, well, can't we just dig up a sample? Like, no, we got to move this way. It's important, we got to get the right sample. So it was a very realistic scenario, and I kind of understand where the engineering frustration now comes from when working with scientists, but it's very appreciated, and we did a good job. So here's the site where we decided to take a sample. We had a rock that looked of interest to our biologist, and we picked it up along with some of the soil surrounding it. So we had a little baggie attached that we could flip the scoop back, and all the soil would fall into it, and we could keep digging, so we could grab samples in stages. We didn't have to go for one big scoop at once. And you can see our cameras positioned far off to the side there. It allows us to get a good overview of what we're working on. So here's our sample. It's about 160 grams total, so we fit well within the limits. After day 1, we retired our railgun. No longer needed because all of the tasks requiring the arm were complete. So there it is, one final go at it. Here's us driving up to the first supposedly unreachable marker. Was no problem for our chassis though, which saved us time in triangulation. There's another one we could drive up to. Here is the Astronaut Task. This is the one we were most afraid of. We had the most trouble with this last year. It's where our rover broke its chains, and we never even saw the astronaut that year. So this year, we were most prepared, I think, for this one, and also most afraid. But the astronaut was told by our judges to be headed in this general direction when last seen. So we figured we would go through between those two hills and start looking. We also had the help of a last known GPS location, which also was somewhere in that area. So that confirmed that. So we headed over there, climbed up this hill, which wasn't much of a hill. I was hoping to be able to drive over all these hills and stuff because I really wanted to just drive over hills. But it ended up being much easier than that because there it was right on the other side. It only took us 3.5 minutes to find it. So that was by far a record for the event. So we got there, we're like, oh, now what? Is that an astronaut? the guy, our judge, asked, and he said, well, it looks like a spacesuit with a big red number on it. He's like, well, are you calling that the astronaut? I'm like, it looks like one. I don't know. Did you guys put another one out? I don't know. So we confirmed that, and we celebrated. Popular Science was there also to take pictures. Then we had a nice celebration there. We were finally done, and our rover made it in one piece and never broke. That was a really proud moment. Here's an overview of some of the public events we did. OMSI is the Oregon Museum of Science and Industry. It's a very big science museum for children and adults alike in Oregon. It was very important. We had a few high school robotics challenges, OSU alumni event. Union Bank asked us to come to their lobby, and we ended up getting on live TV for that. We had an OSU football team promotional event, which Kevin mentioned a few days ago, or I think, was it Dr. Zubrin? I think it was that. And yeah, that was pretty great. We were able to drive with the football team. You see video of that as well. We had a presentation at the ASME conference. We were present at our own College of Engineering barbecue. We had public competition rehearsals in a local park that we would announce in newspapers, and the public came out to that. We were at the Ocean Engineering Expo, which showcases senior design projects. RoboShock is another robotics competition, start sessions for incoming freshmen, as well as the Da Vinci Dates, which is a science and art festival in Corvallis held every year, and it's very popular. A lot of people show up for that. During all these events, we drove a rover around, often involving driving over people, which we first did at this event. Here is Oregon Governor candidate Chris Dudley. He was there. He was very interested in our rover. Every time we go to these events, we discuss, URC, the Mars Society, and robotics and stuff like that. So here's our first record of 33. 33 students that we drive over. You can see here the rover's still tethered. This was early on in the testing process. This is probably about February or so. Then we went to another robotics event there. Here's us at the alumni event dancing with the rover on the dance floor. It was great. It was a very formal event, but here's a university robot spinning circles on a dance floor and skating around. Here's us driving over our football team. This is sometime in May. And here's us in the park with some kids. You see one of our team members dressed as an astronaut. He was the one we used to practice finding. We asked all these kids, do you guys want to be astronauts? They're like, yeah, we want to be astronauts. Except one of them wanted to be a train driver, and I'm going to ask you which one you think that is. Here's some more excited kids. And here's an overview of our rover. And with that, I'll show you some of the videos. They're going to be all back-to-back. So I'll start with the football team, then I'll show you some of our camera's performance, then I'll go through all the different competitions. So here's us driving over the football team. We didn't expect they'd be so excited about it, but they sure had a good time. And we didn't think football and robotics would mix so well. They definitely did. So that was great fun. And all these videos, by the way, are, most of these videos are available on YouTube. You can just search OSU Mars Rover, and tons of them will pop up. Even if you just look up Mars Rover, on the first page on YouTube, one of our videos comes up. So here's a demonstration of our camera. We're sort of zoomed in on an area here. This is after looking for the astronaut, and you'll zoom out, you'll see how good the zoom actually is. It's 432x. So helped us find the astronaut that way. Here's us picking up the plug. It's all sped up, and we cut out the boring section, so it looks like it's a lot easier than it was. But this shows you the view that we had. I'm controlling the camera, and my buddy Joe, he's the one driving the arm. And you'll see up here pretty soon, there's going to be a little spider that pops up on here, and he's going to hitch a ride on the rover as well. There he is. And each of those flashes are snapshots that we take with the camera, so we have pictures. There's a spider on the rover, and there's us plugging it in. And here's the video that one of the judges took. And this is us trying to attempt the last plug, but we realize we're running out of time, so we just back off and drop it and gun it for home. You can see how we're using our steering system there, all our wheels turning. We can even move forward while the wheels are like this. So all that sort of thing saves us time. And you can see we have the immense ground clearance there as well. We had about 10 inches of ground clearance while our center of gravity was only 11 inches from the ground. So we had a very, very stable and very high ground clearance robot that can drive over any kind of terrain. So it was a pretty amazing design. And here's the sample return task, also highly sped up about 4 times actual speed. You'll see us investigating the first site you saw pictures of. Looking for a sample, I was very hoping we could just pick one up. If we could see about what we were doing here. And you can see here the wheels are sort of pointed inward as well. And when we're parked on slopes, we use that as our parking brake. It worked really well. So here we're going to start taking panoramic pictures, also a requirement for the event. Every site you had to get sort of a contextual picture to see where the site was located. So we'll start that here. Each of those flashes is our picture that we're taking. So our camera was very good. We had very good control of it. When we zoomed in, we had our software guy slow down and make our controls more finely tuned. So even while we're zoomed in, we can move precisely. And when we zoom out, we can get big scans. Here's us at the actual site where we're digging. You can see our view of our scoop. Up here is our high-resolution camera that we were also able to switch to. We use that for taking high-resolution shots of the sample we're about to pick up, which was also required. And you'll see when we grab a sample, we'll lift up the scoop and gobble it up and let it drop into the bag. So we could have kept digging and filled up the entire bag with dirt and probably brought back a 400-gram sample, but that wasn't required and not necessary. So quite an ingenious arm control there. Here's a video put together by Kevin's team. And that's showing our, let's see if I can get audio going on here.
There's not a whole lot of audio on this.
Not sure if you can hear that, but there'll be some questions here at the end when we're done. And a nice final statement as well.
Yeah, guys. Can we step up in front of it now?
Yeah, 338. Is there any radio signal from that old?
We drove towards the marker, and then we saw some footprints, so we kept driving, and we saw right over the ridge, and we saw something that looked like a spacesuit, so went right for it.
Easy, right?
Well, it's a year of hard work. Yeah, makes it easy. So I think that's a pretty good summary. That if you spent the time and you go through all the testing, a year of hard work does make it easy in the end. If you do all the hard work in the end, it should be easy, and that's what we were going for. So we're really happy to be able to do this, and thanks to the Mars Society, and I'm really glad we had the opportunity to educate so many people about space robotics, Mars Society, University Rover Challenge, and I really hope to get more teams to join. So thank you, Kevin. Thanks for this opportunity.
Big congratulations again to the Oregon State team.
Do you have questions?
Yeah.
Yep. If there are any questions,